All right, beautiful moment right here. Good evening, everyone. Uh, this lecture is going to be quite more of a dialogue. We're going to be discussing. I'm going to try and relate with you on this very new topic. You need to understand that this is a very interesting, very simple topic. However, because of the terminologies, it's going to take you a while to get your hands around it. All right. So what I will advise is don't agitate, don't have any form of agitation if you are not yet getting it at the initial stage. Sometimes it may take something else I say for you to be able to understand what I said previously. So try and be calm. Don't be agitating because that's not going to really help in a class like this. So as I said already, this is I'm going to do so much of rambling in the sense that I'm just going to be speaking from my mind, explaining things using different analogies as much as I can, so that at least you're going to be able to understand the topic. Today is not going to be so much of calculation. We're going to be trying to bring you guys into this topic. It's a very interesting topic, and it's a practical topic, one of the core aspects of statistics. So I would love you to really pay attention. It's very simple, but you have to really understand all the definitions. So today has so much to do with explaining terminologies. All right. So brace up, guys, and let's get right into it. All right. If there's anyone that is supposed to be in the class, please try and give them an invite because missing the basics of this topic, you're going to have probably this is the topic that has the most of that experience. That if you have issues with the basics, you're going to have real issues. Like there's no way you don't have issues ahead of the class. There's just no way because it's a very it has to do with so much of definition. You need to understand what this terminology means and what this means and everything. So it's a whole lot. I need to tell you guys, it's a whole lot. It has a lot of aspects to it, but we're going to clarify every one of it in the class. So we just have an hour for this class. Tomorrow we would continue from wherever we stopped today. So guys, if you have to jot something, please get yourself right on point. All right, so the lecture begins immediately right now. We're talking about test of hypothesis. And again, we need to define, of course, everybody knows the meaning of test, but we need to define the word hypothesis. And of course, what's the meaning of hypothesis? Let me try and give you an example. Let's take, for instance, let me look at somebody in the chat box. Okay, the last person I can see the name there is Simi Oluwa Esther. Let's say Esther says that, let's assume there is a general belief that the weight of everybody in the class is equals to 25 kg. So don't worry about what I'm writing. I'm going to explain to you later. So we said the weight of everyone in class is 25 kg. Now, for some reason, Simioluwa Esther says, I don't believe this. So she says, I don't believe the weight is 25 kg. Now, pay attention to this. She can say, I believe that people's weights are actually greater than that. That's a possibility. That could be an hypothesis she's making. I will define hypothesis very soon, but let me start from this example. So Esther is saying, uh, the weight of people in class. I look at these people in my class and I believe they are very weighty. I don't believe these guys are 25 kg. I believe they are way more than 25 kg. Now, in that case now, Esther may be producing an alternative hypothesis that I don't accept this. So she's saying the weight is greater than 25 kg. All right. This is an hypothesis. This was the default hypothesis, the one that everybody believed. It was already standard. That's okay. Everybody said the weight of people in this class is 25 kg. Or Esther woke up and said, I feel people in this class are going to be more weightier than 25 kg. Now, this can be, you can test for this hypothesis. Test of hypothesis. You can subject this hypothesis to a test. I'm going to get right into it very soon. You will understand how simple this thing is. Now, because we cannot just say because Esther said that the weight is greater than 25 kg, we're now going to say, you know what, since Esther has said it, we're going to knock off the default hypothesis and we're going to establish that the weight of people is greater than 25 kg. No, that's not how things work. In mathematics, you have to prove things. Everything remains the same until proven different. So we have to subject this to an hypothesis testing. So we'll go on to test this. Now, peradventure, when you are done with the test, you notice that what Esther said was true. Then you will have to now reject this one, the default hypothesis, and establish what Esther is saying. That's all about hypothesis testing. That's the thing we want to be doing from now up till I don't know how long it's going to take. We're going to be testing different hypotheses. You're going to be having different real life experiences. We're going to be subjecting it to different testing. Now, there are many ways to go about testing. That's why you'll be seeing different techniques. All right? You'll be seeing different techniques. We're talking about the t-test, the z-test. All right? When it's all about, number one, first understanding the reason why we have to do this testing. Now, listen to another scenario. It's possible that Esther did not feel these guys were greater than 25 kg. It's possible that Esther just looked at them and felt, is it these small people? You guys are telling me that these people are up to 25 kg. No, I don't believe that. Now, in that case, the hypothesis she will be presuming then will be that the weight is less than. Can you see a different way you can write this hypothesis? You see, the first one I wrote when she said, I believe people are more weightier than this. Now, in another one, she's believing that people are less weightier than the default belief. She believes that people no reach this 25 kg. All right. Can you guys still hear me? Please indicate if you can still hear me. Are you guys still here? Can you still hear me? All right. All right. Thank you very much. So as I was saying, if she decided to say the weight is not up to 25 kg, in that case, this is how she's going to be setting. Now, there's another scenario where imagine Esther just says, I see that you guys said the weight of people in this class, the average weight is 25 kg. Now, I don't know if these people are more than 25 kg. I don't know if these people are less than 25 kg. One thing I'm so certain about is these guys are not equals to 25 kg. In that case, we will have a different scenario. This is how you're going to write that. You can see. Look at it. So right here I've given you 3 different scenarios where the person questioning the initial hypothesis, default hypothesis, will be saying it's greater than, it's more than what was stated before. Another scenario is when the person is saying it's less than. Another scenario is when that person is saying, I'm not sure if it's greater than, I'm not sure if it's less than. I just know that it's not equals to. Now, guys, this is me taking you guys ahead, and I think this is really good because you guys will become, when I start to explain so many things, you guys will be very sound in it. Pay real attention to what I want to say now. Those three different scenarios will give birth to three different types of testing, which is, we say left tail test, we say right tail test, and then we say what? All right. So sorry about the network. All right. I'm sure you guys can hear me now. So we have three different types of testing, and we'll be having these two tests. These two we wrote here. They are both one tail test. So we can have this classified as one tail test, two tail test. Under one tail test, we have the left tail test and the right tail test. Guys, are you still with me? Can you indicate if you're still with me, please? Are you guys still with me? So as I said, I want to take you guys ahead, then we'll come back. Then using that way, I'm sure you guys will become, there are certain things that you will not struggle with. Now, look at what we have here now. Let me explain these three different types of tests. They are all very simple. There's nothing hard about it. The names are just what you are just going to get used to. Now, the first scenario I said, Esther said, I said this. She just said, you said before that everybody believed that the average weight of people in class was 25 kg. Esther is saying, people's weight, these guys I'm seeing here are bigger, fatter. I believe they are going to be more than 25 kg. I believe the average weight is going to be more than 25 kg. This is a one-tail test. Let me prove that to you. This scenario, this is it right here. I'm sure now, at least at this point, you already know how to draw your symmetric curve and everything. If you're going to draw your right tail test, this is a right tail test. This one we have here is a right tail test. And how do you do that with a diagram? Just like as you're already used to doing this, you're going to just have like you are going to separate the curve this way, and you're going to indicate your type of test by shading the right section. So a right tail test, this is how it looks like. Of course, if Simi said we are not talking about greater than, we're talking about less than this case, this will be a left tail test. In this case, I'm sure you know what to do. Instead of having it this way, you'll be having it this other way. So you'll be shading the left-hand side. These are both one-tail tests. Can you see why we call it a one-tail test? We are going to be shading one tail. This is what we call the tail. For this distribution, this metric bell curve, bell-shaped distribution, these are the tails. I'm sure you know that already. These are the tails. All right. So when you are separating and shading the right tail, we're going to be talking about the right tail test. When we're shading the left tail, we're going to be talking about a left tail test. These two are both one tail tests. You can see that we are more concerned with just a particular tail That's why we call it a one-tail test. It is one tail we are interested in. So if Simi was disagreeing with the default hypothesis, and what she is saying is that the average weight is less than 25 kg. In that case, in order for you to test this, you will have to subject this whole thing to a left tail test. This is how it's going to look like in this case. Now, and the last scenario, which is when I said Simi did not say if it's less than or greater than. She just said, I'm not sure if their weight is greater than 25. I'm not sure if it's less than 25. What I just know is that it's not equals to 25. She's challenging the default hypothesis. So this is what she's presuming, that no, the average weight cannot be equals to 25. I believe it's not equals to 25. I'm not sure if it's less than. I'm not sure if it's greater than. In that case, you'll be having a different one. I'm sure you can guess what's going to happen. We'll be shading both tail in this case. This is what we call a two-tail test, because she is not particular about if it's greater than or if it's less than. So this scenario where you have not equals to, whenever you have your hypothesis set this way, when the alternative hypothesis is not equals to, this is going to be a two-tail test. So this right here is a two-tail test. This right here is a left tail test. This right here is a right tail test. So this is just introduction to testing in statistics. So let's go on now to try and define certain terminologies, which is very vital, so that I'm sure this is clear to everyone. Can you give me feedback? Do you guys understand this very much? Or is there any issue with this? Right tail, when you have greater than, of course, you're talking about the right tail. When you're talking about less than, you're talking about left tail. When you're talking about not equals to, of course, you can't say if it's less than or if it's greater than. So in that case, you'll be talking about a two-tail test. All right. So let's come back to the definition of the word hypothesis. From what I've said now, I'm sure you guys can even make a definition of the meaning of hypothesis. Hypothesis is a premise or claim that we want to test. The use of the word hypothesis is more like something that is still subject to testing. All right. Hypothesis. It's not yet, there are no conclusions yet. So hypothesis is a premise or claim that we want to test. In this example I give now, the premise we wanted to test, the claim before was that people said the average weight of people in class was 25 kg. That was one hypothesis. One other person came up and said, I disagree with that. So this is hypothesis testing. So we can define hypothesis as a premise or claim that we want to test. Now, the next thing I want to now talk about is the types of hypothesis. I'm sure from what I've been saying, you guys can bring out the two different types of hypothesis, which is what we highlighted right here. These are the two different types of hypothesis. The first one is what we call the null hypothesis. The null hypothesis. Now, this hypothesis is another way of saying this is the default hypothesis. The one that was already established, the already established belief or claim. Something that was already established, that everybody already believed was the case. All right. And then the second one we have right here is what we call the alternative hypothesis. The alternative hypothesis. With the hypothesis which H and subscript not. H subscript not. H naught. We call this H naught. And then we denote the alternative hypothesis which HA. Sometimes you may see it as H1. So if you see it as H1, don't feel different. It's still the same thing as the alternative hypothesis. So these are the two different types of hypotheses we have in statistics: the null hypothesis, alternative hypothesis. So when you're talking about null hypothesis, as I said already, this is the claim that already exists, that it's already the believed one. So we say it's the established, it's the default. We call it the default hypothesis. Is what has already been established. So the alternative hypothesis is the premise or the claim that brought about the research into that. More like somebody say, with what I'm seeing right here, I'm not going to agree with this. There are many examples you can see under hypothesis testing. So many. Like for instance, let's say you guys believe that a Coke bottle weighs when it's filled up, a Coke bottle uh is 5 gram. Like a Coke bottle is 5 gram. That's what the company told you guys. That when you see a Coke bottle, know that that Coke bottle must weigh 5 gram. Now, some people, probably some students, they bought uh, different different beverages, and they discovered that I'm not sure this thing is 5 gram. So they begin to suspect that this what this guy said. I'm not sure this thing is 5 gram. I believe they've reduced this thing. This thing is less than 5 gram. All right. Now, you cannot just go on to say this thing is less than 5 gram, and then we're going to just push it out there and say we are going to ignore what the company is saying. See, from now on, the Coke bottle, we are going to say the Coke bottle is less than 5 gram. No, you can't do that. You have to subject it to hypothesis testing. That claim you are having, that thing you are trying to establish, you have to subject it to hypothesis testing. So in that case now, you could write not. This was what the company has said. The established belief was that the average of a Coke bottle when it's filled up is 5 gram. All right. Now, you guys saw that I'm not sure this thing is right. So you guys said we are believing that the company are cheating. We're believing that people the Coke bottle weighs less than 5 gram. Now, you may be right, but you cannot just go on to run with that. You have to subject this to hypothesis testing. Now, guys, before I go on, what kind of test are we going to be doing in a case like this? Can anybody write it in the comment section? What kind of test is this? Is this a two-tail test? Is this a one-tail test? And what type of test is it? Just can you tell me quickly? Do we have an answer here? Left tail test. Okay. Somebody said this is a left tail test. Do you guys agree with that? Okay, this is a left tail test. Obviously, I told you when you have less than, it's a left tail test. Good. You guys are learning something. So we have different scenario, and one of the important things you guys must know how to do when dealing with hypothesis testing is you must know how to set your hypothesis. Now, let me quickly tell you something that always happens in the exam. You won't always get questions that give you the hypothesis. So you need to be very, very, see, I'll be entering several aspects on hypothesis testing very soon, much more very soon. Of course, not in this class. You need to pay attention to how we set our hypothesis. It's very simple, and you need to know how to do it, because sometimes they'll just give you a word problem and they will expect you to bring out the null hypothesis. Of course, as I have told you already, the null hypothesis is the claim that has been established. So according to the question, when you see the way the question is being written, you know already that they are saying this thing already exists. That thing they are saying already exists, that has been established, is what you will set as the null hypothesis. Now, whatever they said somebody was saying is going to be the alternative hypothesis. So understand how it always goes. So guys, you're going to write, I want to see how you're going to fare with this. Let's go on to set some few hypotheses. And I will see, just give me your answer in the comment section. Now, pay attention to the formatting of the question. It is believed that a candy machine makes chocolate bars that are on average 5 gram. Look at it. It is believed that a candy machine makes chocolate bar that are on average 5 gram. A worker claims that the machine after maintenance no longer makes 5 gram. All right, let me read the question one more time. You guys will tell me what the H naught and the HA is. All right. Now look at it. We said, it is believed that a candy machine makes chocolate bars that are on average 5 gram. A worker claims that the machine after maintenance no longer makes 5 gram bars. So write H naught and HA. H naught, of course, write the null hypothesis. Now, the question said it is believed. It is believed, of course. That tells you that that is the null hypothesis. That the candy machine makes chocolate bars that are on average. That means the mu. You see the way we set the hypothesis. You write H naught, you put a semicolon, then you put the whatever the parameter you're dealing with there. In this case now, we're dealing with average. So in some cases, we'll be dealing with proportion. In that case, we'll be writing P. You'll see an equation like that when you're dealing with percentages. In that case, now you're writing P, not H. So when you average, of course, you use the population mean. Now, let me get you guys into something I want you guys to understand. A measure obtained from a sample data is called a statistics. If you have somewhere to write something, please write this down. A measure obtained from a sample data is called statistics, whereas a measure obtained from population data is called parameter. That's the difference between parameter and statistics. This comes out a lot. It came out last year, so try and note that. Parameter is a measure obtained from sample data. So obviously here, this parameter here was that the mean, mu, the question said, it is believed that a candy machine makes chocolate bars that are on average 5 gram. That means they said the average is 5 gram. All right. Now, a worker looked at what was going on in the company and said, after they did maintenance on the candy machine, he doesn't believe that the machine is now bringing out bars that are 5 gram. He believes it's no longer 5 gram. Now, look at the question. He did not say he believes that the candy machine is now making less than 5 gram. He did not say it's greater than 5 gram. He just said it's no longer 5 gram. In that case, thank you. I love the answers I'm seeing. That means you guys are really following. It's not equals to 5 gram. This is the null and the alternative hypothesis. All right. Now, let me quickly, of course, I want to tell you guys some very important things you need to note on that test of hypothesis. When you subject a particular premise or claim to testing, like in this case, whichever case you are dealing with, you would always have two conclusions, one of two conclusions rather, and this is it. It's either at the end of your testing, you're going to be rejecting H naught, or you will not reject H naught. Now, I need you guys to understand, it's important you understand statistical terminologies. When you are talking about hypothesis testing, you use more of the word do not reject rather than saying I accepted H naught. No, it's not the right language to use. Even though do not reject meant you actually accepted H naught. But a better way of writing it as an answer is at the end of your testing, if your decision rule brought out the fact that you are deciding not to reject H naught, you will say we do not reject H naught. All right, we do not reject H naught. That means we do not reject the null hypothesis. So you are either rejecting H naught or not rejecting H naught. Now, of course, if you reject H naught, that means you are mostly accepting HA, the alternative hypothesis. And if you do not reject H naught, that means you are obviously accepting the null hypothesis. But the particular way to say this is by saying reject H naught or do not reject. Those are very, very important things you need to note. All right. Now I want to take you guys a bit. These next things I want to talk about, please. You may forget. Please don't forget anything I said. Though that's a joke, but don't forget this next one. It comes out even in undergraduate question. It was a very common question. So don't forget anything I'm saying. Everything I'm saying is very important. All right. And these are the two things. It's called type 1 error and type 2 error. Very, very important. These are very, very important things you must note. Questions like this come out a lot. Define the following terms: type 1 error, type 2 error. So make sure you pay real attention to this. So what is type 1 error? All right. And what is type 2 error? Just listen up, and you will see how simple it is to understand. Type 1 error is the error all right. Type 1 error. This is type 1 error. Type 1 error is the error you make. Is the error we make when we reject the null hypothesis. That means we reject H naught, or H naught is true. That's type 1 error. All right. Type 1 error is the error we make when we reject H naught when H naught is true. Can you guys hear me, please? This is a very important lecture, so I don't want you guys to miss out anything. Please, can you indicate if you can hear me? I want to be sure. Okay. Can you hear me? Please indicate if you can hear me. Is it okay? Can you hear me? It's still skipping. Okay, you are hearing me now. Okay, that's okay. All right. So as I said, let me do a recap quickly. I said type 1 error. Type 1 error is the error we make when we reject the null hypothesis when it happens to be true. So this is the summary. When you reject H naught when H naught is true, you have committed a type 1 error. All right. Now, okay. All right. So type 1 error, you reject H naught, but H naught was true. Of course, you have committed an error because you're rejecting H naught when H naught was true. Type 2 error, you do not reject H naught, but H naught was false. So do you guys get the whole point? Type 1 and type 2 error. All right. Can you guys indicate if you can hear me? And if you can get if you really understood what I was saying? Okay, good. So that's type 1 and type 2 error. So that's something you need to note. Please note it very much. It comes out in theory questions where they will tell you guys to explain those two things. And it's very simple. It's that simple. Error you commit when you rejected H naught when H naught was true is type 1 error. When you do not reject H naught when H naught was false, it's type 2 error. All right. So let's go to another terminology. All right. Another terminology, this is more of definition of terms and trying to expose you to many of the different terminologies we have under hypothesis testing. Good. Let's talk about something called test statistics. Very, very vital. Test statistics. Note all these things, please. Test statistics. Let me explain this. Good. Now, test statistics is calculated from sample data. Note that. We calculate this from sample data. And it is used to decide. So, with all these things we have been saying, we're talking about test of hypothesis. You see, this test statistics is a very vital part. Don't forget, I told you guys not so long ago, I said a measure obtained from sample data what did I call a measure obtained from sample data? Can anybody write it in the comment section? A measure obtained from sample data is what? Statistics. And I said a measure obtained from population data is what? Parameter. So when I say test statistics, you obviously understand that this statistics, it's pulling its values from sample data. So number one, note that test statistics is gotten from sample data. And this test statistics is very, very important. You will see it very soon when we're dealing with, when we start getting into testing. It's very important, and it's used to decide. Is this test statistics used to decide many things? Many things. You actually use it to decide if you're going to reject or do not reject your null hypothesis. Now, we say it's coming from sample data. We use the test statistics to determine if the data that we have is statistically significant enough for the null hypothesis or not. A lot of big words there. Let me try to break it down. So you see, whatever scenario you are dealing with, probably let's try and use the case where this complaint said their chocolate bars have an average of 5 grams. A worker said, I don't believe it's 5 grams because maintenance happened. The machine is no longer producing this quality of chocolate bars. Now, look at something that will happen. For you to conduct this hypothesis testing, you need this value. This is a value. We said it's obtained from sample data. This will just be one value. It's not many values, one value. For instance, 3.29 can be the answer. It can be minus 1.86. Value is always obtained from sample data. All right. And it's always dependent on the kind of test you are dealing with. So let me give you an example of test statistics. When you're dealing with z-test, don't bother so much now. Don't bother so much now, as I said. Don't go on stressing on this formula yet. Of course, it's just an introductory class. You see what I wrote right here? This is the test statistics. This is how you get your test statistics when you're dealing with z-test. When you're dealing with z-test, this is how you get your test statistics. Now, I say it's obtained from sample data. Now, let's look at what we have right here. This first value here, this is the sample mean. This value we have here, S, is the sample standard deviation. This N is the sample size. Now, this mu naught is obviously the hypothesized mean. That was what you had here initially. So this is the only value that you'll be getting from, of course, your hypothesis. Your hypothesized mean is what this mu naught represents. All right? You can write it as just mu. Some people write it as mu naught, some people write it as mu. Of course, since I've been writing as mu, maybe I should just leave it as mu. But you need probably one of the reasons why we love to put the naught is so that at least you guys are understanding that it's coming from the hypothesis. That's important to note. Now, we said test statistics is coming from the sample data. Let me tell you what it's appropriate to do in this case where somebody was challenging what the machine was producing. Rather than just making a claim and running off with it and saying, you know what, we're going to conclude, I don't believe the machine is no longer making 5 grams, and now you think you're going to push that on. Is this still blurry, guys? Well, instead of you pushing that on the company and saying your company no longer brings out chocolate bars of candy bars of 5 grams, you would have to subject this to testing. And how you do that? You will go home to pick a sample, probably a sample of 30, probably a sample of 20 chocolate bars. Then, of course, you will obtain their mean. You can see what you're going to be getting from it. You obtain their mean because you want to test it. And this test statistics you'll be using to determine either rejecting or do not rejecting. This is the formula if you are conducting a z-test. I'll tell you very soon about z-test and t-test and all the likes. This is just introductory. So if you're conducting a z-test, if you're using a z-test to test that scenario, this is how you obtain your test statistics. So when you bring out, let's say 20 bars of chocolate, you get their mean. What's the mean, right? Now you ask from the sample you brought, probably the 20 sample you brought, you find the standard deviation also. And also, of course, if you're using 20 sample size, then your N will be 20. You will solve it, you will push it into this formula, you will get an answer. Is it still blur? Is it still blurry? Can you guys indicate if you can see clearly? It looks like I'm getting comments about it being blurry. Let me get a comment on if you can see the board clearly. All right. Okay. All right. Okay. So after getting the 20 sample of candy bars, of course, you get their sample size, you get the sample standard deviation. Of course, the sample size, if it was 20, you put it here. You get the value. You get the value. It could be, let's say at the end of everything, you get 3.29. This value, very, very important. It's on this value you're going to make your decision. I will tell you how you use this value very soon. Of course, we're not getting into solutions yet. I'm just trying to bring you statistics. It's actually is that thing you get from your sample data. Of course, sample data is what you if you said if the average rate of people in a class is 25 kg. Now, rather than what Esther was saying that they are not 20 kg, what you will have to do will be to go on and bring about, let's say, 20 students. You get their average weight. You don't just go on to say, I don't believe it's 20 kg. No. What you have to do is to subject it to a test, and you have to bring out samples. And that's why you need your test statistic. You cannot be using one value to make an inference. Inference means conclusion. You can't use one value to make an inference about a test. You can't go and say, because I saw a fat guy in class, that means I'm going to, no, subject it to a test. Fix all those values into this formula. If it was a z-test, get your value. I will tell you very soon, not today, how you are going to indicate if you're going to reject the null hypothesis or not. So guys, let's leave test analysis. I'm sure you guys understand what it means. Let's go to something else again. Critical region of the test. Critical region of the test. You guys are getting into the core of this already. Once you start hearing all these things I'm saying, you understand you're already getting closer and closer into real solutions. So we're talking about critical region of the test now. Critical region. Critical region of the test. Region is rejection region. Now, look at what I said. We had 3 different type of tests. Let me use this last one as it was. We had the right tail, we had the left tail, we had the right tail, we had the 2-tail test. What is critical region of a test? It's also known as rejection region, and is a set of values for the test statistics for which the null hypothesis is rejected. That is, if the observed test statistics is in the critical region, they will reject the null hypothesis and accept the alternative hypothesis. Guys, I'm already taking you guys deeper, so it's nice. Look at it. You see these places that I'm shading, all these places where they shade, that's the critical region of the test. You understand it very soon. If your value, your test statistics, if it falls inside this place, if it falls inside this place, inside any of this place, if it falls inside any of all this place, you reject the null hypothesis. You guys are already understanding it small like this. So this shaded part Now that place we call critical region. That's what we call the critical region of the test. Critical region. Another word for it is rejection region. Any of your value that falls inside this place, once, let's say, let me give you an instance. Let's say this place was 1.96, minus 1.96. Let's give an instance. All right. So this line right here was 1.96. This line right here was minus 1.96. Guys, pay attention. You now solved your test statistics. Your test statistics now gave you 3.29. 3.29 was the result your test statistics gave you. I told you this thing is used to decide. Remember when I said it? It's used to decide. You pick this 3.29. You come and check this place. Of course, 3.29 is going to be in this area. Who agrees with that? Is there anybody that disagrees with that? Then this is 1.96 on your number line. Of course, you know that 3.29 will be inside this area. So if 3.29 lies here, see, don't care whatever you are doing. If this is your value for your test statistics, and if this was your critical value, I will tell you the meaning of critical value very soon. This was your critical value. 1.96 was your critical value. 3.29 was your test statistics. You have to reject that hypothesis, the null hypothesis, because it has fallen within the rejection region. Let me give you another example. Let's say this was minus 2.01. This line here, the critical value is minus 2.01. You guys now solved your test statistics. Your test statistics now gave you a value of minus 3.21 as your answer when you are done calculating. Guys, let me ask you. If this is your critical value, minus 2.1, this line is minus 2.01, and my test statistics gave me minus 3.21, will I reject or accept? This is, let's say this was what I was using. This was the test I was using. Am I going to reject or accept? Let me see if anybody is really following. My line, this line, which is called the critical value, my critical value was minus 2.01. My test statistics gave me minus 3.21. Am I going to accept or reject? Of course, I'm going to reject. You say why? I told you guys, once your test statistics falls inside the critical, inside this region, you reject. Minus 2.01, if you know your number line very well, you know that minus 3.21 will lie here, inside this place. So we have to reject. Now, let me ask another question. What if I got minus 1.2? Am I going to reject or accept? If 21. Minus 1.21. Am I going to reject or do not reject? If my test size gave me minus 1.21, of course, I will accept. Of course, I say don't use so much of the word accept. You use do not reject. Because minus 1.21 obviously is not inside this region. It's obviously going to be around here. So in that case, you do not reject. That's the hang around this thing. It's all about understanding this terminology. This thing is so simple. If you guys can start rubbing your mind around this, you will see that for you to get your final answer, all you have to have done is number one, find your test statistics. When we start solving, you will see that it's too simple. These things are too simple. Get your test statistics. Of course, I'm going to explain to you how you get these values very soon. I'm not sure if it's going to be in this class, but very soon I will explain to you how you get values. So I think I saw a question asking, don't bother too much. These values, minus 2.01, there's a way you get them. All these values here, there's a way you get them. I will tell you how to get them very, very soon. Now, the test statistics also, I gave you a formula for Z test. There are other test statistics with different formulas. I'll tell you how to get it. So you need to know your test statistics. You need to know your critical value, and then you need to, of course, know if it's falling inside the critical region, or so we can say critical region, acceptance region. So in this case now we'll be saying this is the critical region or the rejection region. This is the acceptance region. So anything that falls inside this place we'll be accepting. Anything that falls inside this place, this is rejection region. This one are the acceptance region. This one right here, this is rejection region. This one acceptance region. That's the way these things work. So you just need to understand all these things. All right. It's quite very, very simple. Now, let me get quickly to what I said, critical value. You know, I mentioned critical region now. I said, let me say critical region again for you to wrap your head around it. I said, it's also known as the rejection region, the set of values for the test hypothesis for which the null hypothesis is rejected. That is, if the observed test hypothesis is in the critical region, then we reject the hypothesis and accept the alternative hypothesis. Critical value is the value of the test statistics. Critical value now, value, not region. Region is a whole space. Value is a value and a figure, an answer. So critical value is the value of the test statistics which defines the upper and lower band of a confidence interval, or which defines the threshold of statistical significance in a statistical test. All right, I'm going to stop right there because I don't want you to stress too much this night. We're going to continue from the use of the word critical region, critical value rather, because for me to explain what I just said now, I said it's the value of the test statistic which defines the upper and lower band of a confidence interval. Confidence interval. Confidence interval. That confidence interval, I need to explain it, and that's where I'm going to be starting from tomorrow. Confidence interval. All right, it's a very important aspect. Confidence interval, confidence level, level of significance. We're going to be starting from there in the class tomorrow. So guys, how do you feel about this? Are you very confident that you are going to really understand this very greatly? How do you feel? Give me your feedback quickly before we move on. How do you guys feel? Quite very simple, I guess. But you understand the importance of tomorrow's class because we're going to be continuing from this wave. We're going to be continuing from this wave, and this video will be available right around 11 or so. So if you came late, of course, I told you guys already, coming missing the terminologies may really bring so much confusion, but you have to just go back and watch the whole thing and you'll be good. All right, so guys, thank you very much. We'll be continuing from where we stop tomorrow. Thank you very much. Do have a beautiful night. Take care of yourself. Bye.